So once again, we will continue. So we will call the induction motor as a rotating transformer. Okay. So if you consider a transformer, so transformer is a static device. So induction motor is going to be a rotating device. So what is the difference between induction and conduction? So we discussed about DC machines. So DC machines is based on induction or conduction. So what is the meaning for conduction and induction? Then we will enter into the induction motor. So if you know the answer means you can post in the chat box. So here we are going to discuss only the induction motor. But before that you should know what is meant by conduction. So here we'll have, if we consider machine means, so we'll have a stator and a rotor. So we consider DC machine and the induction motor. That is, you can consider as AC machine. Okay. Hello, Nagaraj sir, கேக்குதா?
கேக்குது சார்.
நாகராஜ் சார்.
சார் கேக்குதுங்க.
ஹலோ, நீங்க பேசுறது கேக்குது. இப்ப சவுண்ட் கேக்குது. இப்ப பேசுங்க.
கேக்குது சார். சார் பாடிங்களா? சார் கேக்குதா?
சரி, அப்படின்னா நான் வந்து அப்படியே கட் பண்ண தேவை விடுங்க. சரி, சார்ஜர் மட்டும் கொஞ்சம் எடுத்துட்டு வாங்க. இல்லை சார்ஜ் மட்டும் நிற்காது, இது வந்து பண்ணி மீனாட்சி சுந்தரம் கேக்குதா? கொஞ்சம் நீங்க பேசுங்க, அன்மியூட் பண்ணி.
சார் கேக்குது சார்.
ஹலோ
சார், ஆடிபிள் சார்.
ஆடிபிளா?
எஸ் சார்.
ஓகேப்பா, ஓகேப்பா, ஓகே, தேங்க்யூ. இது கால் கட் பண்ணி கனெக்ட் பண்ணா இது கனெக்ட் பண்ணிக்கோங்க சார், கனெக்ட் ஆயிடும். சரி சரி, கட் பண்ணிட்டு ரீகனெக்ட் பண்ணலாம். ரீகனெக்ட் பண்ணோம்னா ப்ளூடூத் இதுலயே கனெக்ட் ஆகும் சார். அது இப்போ பண்ண வேண்டாம், கிளாஸ் கட் பண்ண வேண்டாம்னு சொல்லிடுங்க சார். இதுல கனெக்ட் பண்ணி. சரி சார், ஓகே. இப்போ அவங்க பேசுறது உங்களுக்கு கிளியர் தானே சார்? கேக்குது கேக்குது. சார்ஜ் மட்டும் சார்ஜ் மட்டும் எடுத்து சொல்லுங்க. அதில் போட்டுக்கலாம். இங்கே பின்ன மதியமா வாங்க, ஃப்ரீயாக. Okay, so we will continue. Okay. Hello. So this is the syllabus we are going to discuss. Okay. So what is by conduction and induction means if both the stator and rotor are receiving supply. So in the case of DC motor, so we'll have a stator, we'll have a field winding and armature winding in the rotor circuit. So both will have a DC supply. So on what principle the DC motor will work means it will work based on the conduction principle. Okay. So regarding the induction, what is the induction means? So we'll give only the supply to the stator. So rotor will automatically it will work. Okay. So for the rotor we are not going to give any input to the rotor circuit. So we'll call this as a induction. Okay. So this is the main difference between the induction and conduction. So in the module 2 second half what we are going to discuss means so three-phase induction motor. So constructional details of three-phase induction motor, types of rotor, principle of operation, what is my slip torque characteristics, and its equivalent circuit similar to transformer. In transformer we will have equivalent circuit. Like that in induction motor we will have a equivalent circuit. Torque equation, condition for maximum torque, losses, efficiency, starting methods, soft starting of three-phase induction motor. So these are the topics we are going to discuss. So in the case of module 2 second half. And here, so the construction of the three-phase induction motor is similar to the transformer. So if you consider three-phase transformer, so we'll have a three winding, okay, RYB. So we'll have a three winding. So similarly in the case of rotor circuit, we'll have again three windings. So suppose if we consider
Sir?
so what are the terminals we call this as A1, A2, V1, V2, C1, C2. So that is given here A1, A2, so V1, V2, C1, C2, we call this as A1. So similarly, here also we have A1, A2, so V1, V2, C1, C2. A1, A2, V1,
Sir?
and then C1.
Sir, வாய்ஸ் சுத்தமா கேட்கலங்க.
We have a transformer and induction DC. So similar windings will be available in the stator side and the rotor side. We have three windings on the stator and three windings on the rotor. Okay. And here we'll have the rotor. In the case of transformer, we'll have a stationary part. So in the induction motor, the stator will be stationary and the rotor will be rotating. So this is the terminal rotation. This is the small introduction about the induction machine. So how the induction motor is classified? So based on principle of operation, we'll have a synchronous motor, asynchronous motor. And what is meant by asynchronous motor? You know synchronous motor. So what is meant by synchronous motor? So what is meant by a synchronous motor? So now it's audible, clear?
Audible, sir. Yes.
Now it's clear.
Yes, sir.
Okay. So what is meant by asynchronous motor? What is meant by synchronous motor? So charge மட்டும் கொஞ்சம் போட்டு. இதுல கேக்கும்ல. இங்க ஆன் பண்ணி இதுல கேக்கும். So what is meant by synchronous motor? So only 1500 is not in synchronous speed. We have different speeds. So So Naras, இப்போ கேட்குதா பாருங்க.
இப்போ ஓகே சார்.
இப்போ ஓகேங்களா?
ஓகே.
சரி ஒரே செகண்ட் இதில் கனெக்ட் பண்ணி கொடுத்துருங்க. இதில் சார்ஜ் அதுக்கு இதில் வாங்கினது நெட் ஆன் பண்ணிட்டு கனெக்ட் பண்ணி. So this all so based on the number of poles. So based on number of poles, so all this comes under the synchronous speed. So 2 is 3000, 1500, 1000. This all this speed. So based on the number of poles, all are comes under the synchronous speed only. Okay. So if the speed of the motor is less than the synchronous speed. The speed of the motor is less than the synchronous speed. So we will call that as a asynchronous motor. And synchronous motor represents if it is operating at 1500 or 3000 or 1000, so like that. So in the case of induction motor, so we have a squirrel cage slip ring. So these two types of motors only we are going to discuss. Okay. So remaining motors comes under the single phase commutator motor, series, compensator, shunt, repulsion. So these all B part will comes under single phase motor. So in this model we are going to discuss only the asynchronous motor. And based on supply we will have a three phase motor, single phase motor, and based on speed we will have constant, variable, adjustable speed. And based on the enclosure we will have a open, enclosed, semi-enclosed, ventilated, pipe ventilated, reverted frame, everything. Okay. So suppose suppose if you are having some application, cement mill, rice mill. So in this type of in this area, so what should be the enclosure of the motor? It should be have ventilation or not? In the case of cement or rice mill, if you are designing an induction motor, so what should be the type of enclosure? It should be open. If you know the answer, please kindly post in the chat box. So if you are having a cement mill means what type of enclosure? It should be totally enclosed, semi-enclosed, or 1/3 it is enclosed. So what should be the enclosure? Because the environment in the environment in the usage of motor is in the pollution area means you should have a totally enclosed motor. And if it not means what will happen, the dust will enter into the machine. So that only we'll have the classification of these motors. Okay. Yes. And next, so this is the general principle of the motor. So we have so how the conversion of the supply takes place. So electrical power is converted to mechanical either by conduction or induction. So as per the AC motor, we have the induction principle. Okay, it is called as a rotating transformer. So the primary is going to be stationary and the secondary will be rotating. So we are having a single phase transformer. What is the need to go for a three phase transformer? Are you having any idea? So we are having already a single phase transformer. So what is the need to go for a three phase transformer? So the rating, if you want to have the more ratings, we'll go for a three phase induction motor. So single phase induction motor will be used for low rating. So single phase induction motor are called as a fractional horsepower motor. Fractional horsepower motor. And if you are having the less than 1 HP, so we'll call that as a single phase, that will be used for a low power application. We'll call that as a fractional horsepower motor.
And if you want to have a capacity more than 1 HP, that is if we need a 5 HP or 10 HP or 15 HP, so we'll prefer the 3-phase induction motor. Okay. So similar to the transformer, we have a single phase transformer is used for a low rating application, and 3-phase transformer is going for a higher application. So single phase transformer generally we will use in the commercial or in the household applications. But in the case of 3-phase transformer, it will be used in the industries, so like that, to supply the power to a particular area. So the rating, based on the rating. Okay. So what are the advantages and disadvantages of the 3-phase induction motor? We have a roughly, afterwards we'll discuss the construction, then you know why this advantage is given here. So the 3-phase induction motor are very simple, and the construction will be unbreakable. It will have a strong construction. Okay. So cost will be low, reliable, and high efficiency, minimum maintenance. Starting arrangement is simple. So before going to discuss what is in the self-starting, so which type of motor will not self-start? We already studied. We have shunt motor, series motor, compound motor, synchronous motor. So which motor will not self-start? We need a additional arrangement. Ashwin, you may tell the answer.
Sir, asynchronous motors.
Asynchronous motor need a self-starting. Okay, good, very good. So similarly, so here we have a 3-phase and single phase. Single phase motor is not self-starting. It will not self-start. So we need a additional arrangement. But in the case of 3-phase induction motor, so it will automatically self-start. If you give the input supply, and it will self-start. So self-starting arrangement is not needed in the case of 3-phase induction motor. So these are some of the advantages. Cost-wise, construction-wise, output-wise, maintenance-wise, and the starting-wise. So if you want to vary the speed, so we'll have some motor will be used for a constant speed application. Some motor will be used for a variable speed application. So similar to DC, so shunt motor will be almost used for constant speed application. So series motor will use for variable speed application. So similarly, so in the AC also we'll have a constant speed motor and a variable speed motor. So if you want to vary the speed, means the efficiency will start decreasing. So this is the disadvantage. And if the load is increases, also speed will decrease. Okay. And the starting torque will be moderate compared to DC shunt motor. These are the disadvantage. So speed control, if you want to do, means either it will you have to sacrifice efficiency. Okay, the efficiency will start decrease. Okay, these are the some of the advantages and disadvantages of a common 3-phase induction motor. It is not based on the types. Okay. So next, coming to the introduction part. So in the stator side, we need a 3-phase input supply, RYB, that is A1, B1, C1, and you have a neutral also. In the case of a 3-phase induction motor, so stators, you know, in stator we'll have windings. So rotor, you will know the rotor will have a 3-phase, stator also will have a 3-phase winding, rotor will also have a 3-phase winding. So in the transformer, we'll have different connections, star, 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 delta, delta, star, delta, delta. So, but in the case of induction motor, so we'll have only one arrangement. What is that arrangement? Means star, star connection. Okay, we'll have a star, star connection only. So stator will be star connector, rotor will also be star connector. Okay, and we'll discuss while coming to the construction. Okay, so what is mean by asynchronous motor? Means synchronous motor means based on the number of poles, so either it will operate at 3000 rpm or 1500 rpm or 1000 rpm or 750 rpm. But in the case of induction motor, it will always operate less than the synchronous speed. So if it is a 2-pole induction motor, it will operate less than 3000 rpm. So if it is a 4-pole induction motor, it will operate less than 1500 rpm. And if it is 6-pole, it will operate less than the 1000 rpm. So we call this as a induction or asynchronous motor. Okay. So in the rotor circuit, we are not going to feed any supply on the rotor side. We are going to have only on the stator side, similar to transformer. So in between the stator and rotor, we'll have a small air gap. So due to induction, the flux is going to link on the rotor circuit. Okay. So this is a general introduction. So we'll discuss to the construction. So regarding the construction, we'll have two types of induction motor. Already in the first slide, we are going to discuss only the squirrel cage and the slip ring induction motor. So what is the difference between squirrel cage and slip ring? Means based on the rotor circuit. So for both the cases, stator will be same. There will not be any change in the construction on the stator side. So only the rotor side is going to be changed. So you can take if you're having the note, means you can note down. So we are going to discuss only on the squirrel cage and slip ring only. Okay, these two motors only we are going to discuss. Okay, that is our syllabus as per the module 2 second half. So this is the basic three-phase induction motor. Okay, so we'll have here RYB as the input supply, and next we'll have the stators. So already I wrote there. We'll have supplies A1, B1, C or RYB. So the windings will be placed like this only. So what is the type of windings we are going to use? What are the different types of windings available? Are you having any idea? What are the different types of windings? As per the DC, what are the types of windings you know? So we discussed about the lap winding and wave winding. Okay. So other than that, we'll have a concentrated winding and distributed winding. Concentrated and distributed winding. So what is meant that a concentrated winding will be, we'll have a bunch of winding will be placed in a slot. So distributed winding will have, if you're having six number of poles are available, a single winding will travel in all the slots. Okay, or a major portion of the slots. So the concentrated winding will have more heat dissipation. So distributed winding will have lesser heat produced. So these A, B, C are called as the stator windings. Okay, then we'll have a air gap. Then we'll have a rotors. So that small circle represents the this small circles represents the rotor windings. Okay. So here we'll have two types of motors. One is squirrel cage, another is slip ring. So based on the types of motors, we'll have either rotor bars or rotor winding. Okay. So here we will have either copper bars will be placed on the rotor circuit, or you will have a windings on the rotor circuits. So this is the case. Okay. And what is meant by RMF? You know EMF, MMF, ZPF, like that you know. So EMF means you will tell electromotive force, and or MMF magnetomotive force, and ZPF means you will tell the zero power factor. So what is meant by RMF? We'll call this as a rotating magnetic field in the case of induction motor. So what is meant by rotating magnetic field? Means this field will be created on the stator circuit. So if you give the input supply, three-phase input supply is given to the stator circuit, and the stator will produce a RMF. Okay, we'll have a distributed winding on the stator side. So that winding will produce a rotating magnetic field. We'll call that as a RMF. So what is the speed of the rotating magnetic field? Means it will be equal to the synchronous speed. And if you are having a 4-pole motor, suppose you will have a 1500 RPM. So the rotating magnetic field produced on the stator, the rotating magnetic field produced on the stator will be 1500 RPM. And due to rotating magnetic field, the flux linking to the rotor circuit will have the speed lesser than the synchronous speed. So suppose if the rotor circuit is short circuited on both the ends. Suppose if we are having here in this case, how the rotor construction will be in the case of so induction machine means, so we'll have a stator winding like this. So this will be the stator winding. So the rotor winding will be almost like this. So this is a RYBN, and that is a, this is stator circuit, this is rotor circuit, and here we'll have a air gap. And you see this arrangement, this is the actual construction of the induction machine. Okay, so in the stator we'll have three windings with the neutral point, and the rotor circuit will be short circuited. So we either will have a winding or copper bars. Okay, and if it is short circuited, and if you are considered a transformer is, if you are conducting a short circuit on test on transformer, then what will happen? We will have a high current on the rotor circuit or in the secondary. So with this principle, we are going to generate the force, torque is going to be generated. Okay. So if the rotor is short circuited, and if you are giving the maximum amount of voltage, so and if you are gradually varying the voltage and you are bringing to the maximum value, so what will happen if it is short circuited, high current is going to be generated on the rotor circuit. Okay. So that current is going to drive the torque. So the motor is going to start when if you are gradually increasing the voltage on the stator circuit. This is the actual arrangement of the rotor circuit. Okay. And then we'll have a shaft, that and all general construction. We have the shaft bearings will be available, and these copper bars will be placed over the shaft. So that and all we'll discuss. So this is the cut sectional view of the induction motor. Okay. So it will not be clear. We'll go. This is the overall diagram. We'll go to the types of rotor. You see this rotor. So first we'll discuss about the squirrel cage rotor. Okay. So this is the actual squirrel cage rotor. So here we'll have the copper bars. So instead of windings, we'll have only the copper bars. Okay. So the
slide is not changing, sir.
Napa? Slide change out.
Slide change a matting, sir. First slide lyrics, sir.
Change aicha. Okay.
சார் அந்த எனேபிள் எடிட்டிங் அதை கிளிக் பண்ணி விட்டுருங்க சார், அதுதான் போக மாட்டேங்குது.
இப்போ வேற ஏதாவது எனேபிள் எடிட்டிங்கா?
மேல இருக்கு பாருங்க சார், எல்லோ டாப்.
ஓகே சார், ஓகே.
சுத்தமா போயிடுச்சு.
சரிங்க சார், ஒன் செகண்ட்.
ஓகே சார், இப்போ அந்த ஃபுல் ஸ்கிரீன் மட்டும் போடுங்க சார். ஓகே சார்.
இப்போ வேற சார். ஓகே,
கிளியரா இருக்கு சார்.
ஓகே. So this is the first type of induction machine, squirrel cage. So here we'll have this black color represents the copper bars. Okay, copper bars will not be placed in straight. Somewhat it will be skewed of 1 degree or 2 degree. Okay. So what is the need to have this type of construction means to avoid magnetic locking. So what is magnetic locking means? If the stator and rotor are aligned, so if it is aligned means what will happen? The rotor is not allowed to rotate. Okay, so it will produce a magnetic hum. Noise will be produced. So we'll call this as a interlocking. Stator and rotor are get interlocked means in the case of synchronous machine, if the stator and rotor are interlocked only, it will run at the speed of the stator speed. Okay. So in order to avoid the magnetic locking, the stator and rotor should not be get locked. And if it is locked means what will happen means, so it will not allow the rotor to rotate. So that only the copper bars are not straightly placed. So it will be placed in terms of skewed of 1 degree or 2 degree. So in order to avoid the magnetic locking. Okay. So this is so if we consider, so this is here it will not be straight. Somewhat it will be skewed. If we see this is called as a copper bar. So in between the copper bars, we have a small insulations will be provided. Okay. So either it will be a mica or paper, so will be provided on the rotor side. So due to the instead of if you are having a winding and if you are using copper bar, what is the difference? Are you having any idea? Instead of using a copper winding, if you are using a copper bar, then what will happen? What is the main difference between these two means? And instead of the winding, if you use a copper bar means the construction will be strong. It will be mechanically strong. and it will be rugged construction. So these copper bars will be short circuited with the end rings. Already I told, so in the board we will have a arrangement. So the copper bars will be placed RYB, like that it will be placed, and I will call it as a end connection. We will call this as a end connection. So in this, on both the ends, here and here, so through the copper windings, so we'll short circuit all the copper bars, and it will be reverted, okay, and it will be welded and reverted. So what will happen means, if the motor is running at a higher speed, so it will not be get loosened, okay, it will be tight. If you are welding means, if it is run at higher speed also, so there will not be any disalignment, or there will not be any flexible in the copper bars. It will be strong, okay, whatever the speed it is running. So what is the, based on the rotor only we are classifying the motor as a squirrel cage and slip ring. So stator will be same. So in the rotor we'll have a copper or aluminum bars, and it will be shorted at the end side, and it will be welded, okay, and it is mechanically strong. So what is the disadvantage of this this rotor circuit means, if you want to go for a speed control, you are trying to go for a speed control, so we cannot be able to add a external resistance in the rotor circuit. So if you go for a speed control means, you need to add the external resistance in the rotor circuit. So this cannot be possible in the case of the squirrel cage rotor. So as per the construction, what are the points you got to remember means, what is meant by magnetic locking? So what is why the rotor are skewed, okay, and the either winding is used or copper bars or aluminum bars is used, and it is short circuited or not. So as per the squirrel cage induction motor, we'll call this motor as a constant speed motor similar to shunt motor. Why means, we are not going to add any external resistance in the rotor circuit. And what is the resistance available in the rotor circuit? With that only we are going to adjust the speed control. Okay, so it will be operated only within the rated speed. Suppose if we are having a induction motor speed will be around 1470, 1480. Okay, we'll introduce a term called as a slip. Okay, what is the slip means? We have this formula for the slip. So slip is equal to ns minus n divided by ns into 100. So this is a notation is S. So what is meant by ns means, ns is called as a synchronous speed, n is called as a running speed. So this is a synchronous speed, and this is called as a running speed. Suppose we take the example, ns equal to 1500 and n is equal to 1470, and what is the percentage you are getting? Percentage means into 100, or you will get in terms of fraction. Okay, so what is the value of the slip means? Slip will vary from 0 to 1. Slip will be generally vary from 0 to 1. When you will have when the n is equal to 0, we get the slip is equal to 1. When the n is equal to ns, we will get the slip is equal to 0. Okay, so the slip, this is the slip, this is the difference in speed. Suppose if the ns is 1500, n is 1470, that 30 rpm is produced in the rotor circuit. Okay, the 30 rpm difference in speed is produced. So this we will call the term as a slip. Okay, and the running speed is try to catch the synchronous speed, but it is not at all possible because the rotor is skewed in construction. Okay, so are you having any doubt on this squirrel cage rotor? Squirrel cage rotor doubt? So we have a shaft. Over the shaft we have these arrangements. We have a bearings. So over the bearings we will have this rotor construction. So instead of copper windings, we will have a bars. Bars will be, it will not be straight, it will be skewed of 1 degree or 2 degree. So in order to avoid the magnetic locking. And at both the ends of the copper bars, it will be pivoted and welded. Okay, in order to have a strong arrangement. தம்பி ஸ்குரில் கேஜ்ல ஏதாவது டவுட் இருக்கா? இல்ல டிஃபரன்ஸ் நீங்க தான் சொல்லணும், அதுக்கு தான் கேக்குறேன். ஸ்லிப் ரிங் பார்த்துட்டு நெக்ஸ்ட் டிஃபரன்ஸ் நீங்க தான் சொல்ற மாதிரி இருக்கும்.
சார் ஸ்லைடு சேஞ்ச் ஆகவே இல்லை சார்.
ஸ்லைடு நான் மாத்தவே இல்லப்பா, இன்னும் மாத்தவே இல்லை. ஸ்குரில் கேஜ் தான் நடத்திட்டு இருக்கேன் நான். இன்னும் வேற டாபிக் நான் மாத்தவே இல்லை இன்னும் ஸ்லைடு. ஸ்லைடு மாத்தினாதான் நான் மொபைல்லயும் வச்சிருக்கேன், மாறுது எனக்கு தெரியும், நான் இனிமே பாத்துக்கிறேன். இது வரைக்கும் நான் ஸ்லைடு மாத்தல. உங்களுக்கு ஸ்குரில் கேஜ்ல ஏதாவது டவுட் இருக்கா? இப்ப டவுட் இருந்தா இப்ப கேட்டுரு. ஃபாஸ்டா போனாலும் சொல்லிடு, ஃபாஸ்டா போறேன்ட்டு. இப்ப மாறுதா ஸ்லைடு? wound rotor. Next we'll discuss about the slip ring.
Yes, sir.
So slip ring, we can have this for the slip ring. So what is the difference between squirrel cage and slip ring machine means? So squirrel cage will be used for a constant speed application, and it is mechanically strong. It will have a simple construction. Efficiency will be more. Okay, maintenance will be minimum. What is the disadvantage of squirrel cage means? Speed control is not possible. Speed control is not possible in the case of squirrel cage induction motor. Okay. So next, coming to the slip ring induction motor. So almost the slip ring induction motor will be like this one. Okay. So we'll have a rotor winding. So in the case of squirrel cage, the rotor on both the side will be short circuited. On the both the side will be gets short circuited. Okay. And in the case of the slip ring induction motor, this motor is mainly used for a variable speed application. Squirrel cage will be used for constant speed application, and slip ring will be used for variable speed application. Here you see on the rotor right side, and the right side of the rotor, on the right side here if you see, so 3 slip rings. Here we have this is slip ring, and this is a brush. Okay. This is slip ring. You will have 3 slip rings and 3 brushes. Okay. So what is the role of a slip ring means? If you want to connect a stationary part to a rotating part. Nagaraj sir, கொஞ்சம் mute பண்ணிக்கங்க. So if you want to connect a stationary part to a rotating part, this rheostat is a stationary part. So rheostat is a stationary part. This is a stationary part, and this is a rotating part. So if you want to connect a stationary part to a rotating part means we need this slip ring arrangement. So this will have a circular shape. It will have a circular shape. Slip rings will be of circular shape. Over the circular shape, this brush will be sliding over that circular part. So you know what is the role of a brush? It will collect the current from the commutator. Generally, you will tell. So it will collect it will have the collection of the electrical parameters from the rotating part. Okay. So the slip rings will be of a circular shape, and brush will be slide over that slip ring. So from the rotating part, so the current will be fed to the rheostat. And if we include the more amount of resistance in the rotor circuit, thereby we can have a variable speed can be obtained in the case of the induction machine. This is the major difference between the squirrel cage and the slip ring. So squirrel cage construction will be similar to what I drawn in the board. So the windings will be short circuited. That's all. But in the case of the slip ring induction motor, so we'll have a slip rings, brushes, and we'll have a special type of starter. We'll call that as a rotor resistance starter. So in that starter only we'll have these arrangements, slip rings and rheostat arrangement. Okay. And this is the major difference. So in the industry, so we'll use maximum type of induction motor. What we are going to use in the industry means we'll use only squirrel cage induction motor. So 95% of the motors used in industry as per induction machine is squirrel cage. Okay. So 5% only we'll go for the slip ring induction motor. So what is the why means? This slip ring induction motor will have a variable speed application. That's all. Remaining all are disadvantage only. So the construction here it will not be strong because we'll have a slip ring, brush assembly, and rheostat. It will not be mechanically strong. The efficiency will be poor compared to the squirrel cage induction motor. And only one advantage means the starting torque will be more and we can have a speed control. So remaining all are disadvantage only. Okay. So this is the, with respect to the squirrel cage, it's a slip ring induction motor. So it's possible to tell some difference between squirrel cage and slip ring. ஏதோ ஒன்று ரெண்டு பாயிண்ட் சொல்ல முடியுமா? இல்ல நம்ம நேம் கூட்டாதான் சொல்லுவீங்களா? இந்த squirrel cage and slip ringல ஏதாவது டவுட் இருக்கா? We will discuss about the comparison table இருக்கு, நம்ம டிஸ்கஸ் பண்ணலாம். So this is the slip ring induction motor. Rotor construction மட்டும் தான் இங்க காமிச்சிருக்கோம். Stator will be same. Okay. So this is the different construction of the squirrel cage rotor. Okay. So it's possible to tell. So what is the other name for slip ring induction motor? Means we will call as a rotor, wound rotor. Squirrel cage rotor and wound rotor. Keerthivasan, சொல்லுப்பா, வேற டவுட் இருக்கா? இல்ல நீ வேற யார்கிட்ட பேசிட்டு இருக்கியா? தெரியாம ஆன் பண்ணிட்டியா? Okay. So it's possible to tell some difference between squirrel cage and slip ring. இத சொல்ல முடியுமா? தினேஷ் பிள்ளை. இல்ல chat boxல போடு, ஏதா டிஃபரன்ஸ். இப்ப டிஃபரன்ஸ் தான் பார்க்க போறோம். டிஃபரன்ஸ் between squirrel cage and slip ring தான் பார்க்க போறோம். தினேஷ் பிள்ளை இல்லவே இல்லையா? தினேஷ் குமார் 109. தம்பி கூப்பிட்டு ஆன் பண்ணீங்கன்னா ஆப்சென்ட் தான். 108, 109. ஹரிஹரன்.
எஸ் சார்.
ஏதாவது டிஃபரன்ஸ் புரிஞ்சுதா? ஃபர்ஸ்ட் உங்களுக்கு நான் இதான் ஃபர்ஸ்ட் டைம் கிளாஸ் எடுக்கிறேன், அதனால கேட்கறேன். உங்களுக்கு புரியுதா? புரியுது
சார், புரியுது.
யார் பேசுறேன்னே தெரியலையே. யார் பேசுற? ஹரிஹரனா?
ஹரிஹரன் சார், ஹரிஹரன்.
சரி, ஏதாவது ஒரு பாயிண்ட் சொல்லுப்பா. ஸ்குரில் கேஜுக்கும் ஸ்லிப் ரிங்க்கும் ஏதாவது ஒரு பாயிண்ட் சொல்லு, டிஃபரன்ஸ். ஹலோ, okay. Sedu, very good. Squirrel cage induction motor is a constant speed motor, low maintenance, high efficiency. Slip ring is variable speed, high maintenance, low efficiency. Okay, very good. Dinesh Pillai, western போடக்கூடாது. சொல்லுப்பா ஹரிஹரன், சொல்லு.
சார், பிரஷ் நோ பிரஷ்.
பிரஷ் நோ பிரஷ். ஓகே, குட். ஓகே, வேற ஏதாவது பாயிண்ட் இருக்கா? ஒரு 4 பாயிண்ட் சொல்லிருக்கீங்க, வேற ஏதாவது பாயிண்ட்ஸ் இருக்காப்பா? மணிகண்டன் 121. மணிகண்டன் எஸ் சார், அங்க போடக்கூடாது. ஏதாவது டிஃபரன்ஸ் இருக்கா என்ன? டர்ன் ஆன் பண்ணி சொல்லு. சாட் பாக்ஸ்ல போடக்கூடாது. மைக்கி ப்ராப்ளமா? சரி, ஓகே. ஸோ வில் டிஸ்கஸ் அபவுட் த மணிகண்டன். உனக்கு ஆப்ஷன் தான் 121. நீ வந்து எதை டர்ன் ஆன் பண்ணி சொல்லு. ஸோ திஸ் இஸ் த டிஃபரன்ஸ் பிட்வீன் த squirrel cage and slip ring induction motor. Okay. So in the squirrel cage we'll have only bars. Okay, rotor bars will be available. Okay. So in the case of slip ring induction motor we'll have windings. Okay. Here we'll have only the rotor bar, and in the slip ring we will have the 3-phase stator windings, and rotor also contains the windings only. So construction will be simple in the case of squirrel cage, and here the construction will be complicated. Okay. So why it is complicated? Why this construction is complicated? Because we are using slip rings, brushes, and external resistance. Okay. So so the construction will be complicated. So here we will have only the copper bars, copper bars will be available, and it is reverted. Okay. Here we will have additional components will be connected. So So in the squirrel cage, external resistance cannot be inserted because at the both the ends they are short circuited. So we cannot be able to add any external resistance in the rotor circuit. And in the case of slip ring, resistance can be added. And fourth point, slip ring and brushes are absent in the case of squirrel cage. And here the slip ring and brushes are present. Okay. So here construction will be robust. That is a strong construction, and it is mechanically strong. And the maintenance is minimum. Maintenance is minimum. So here the construction in the case of slip ring will have a delegated construction due to brushes, and frequent maintenance is needed. So why the maintenance is needed means, so what will happen to the size of the brush when continuously the slip ring motor is operating? Then what will happen? The size of the brush will reduce. Okay. Then what you have to do? You have to replace after a small period. So you have to replace with a new brush. Okay. So it is similar to a brush available in a two-wheeler or four-wheeler or cycle. So it will be made up of carbon material only. It will be made up of carbon. So what will happen? Automatically the size of the brush will be reduced. The thickness of the brush will be reduced. And so you need a frequent maintenance is needed. So here the rotor is cheap because we are not having any additional elements. Here the rotor will be costly. So 95% of the motors we are using only the squirrel cage induction type of induction motor. And 5% only where you need a variable speed applications, so we'll go for this slip ring induction motor. Okay, where you need a high starting torque. So where you need a high starting torque with the load, if you want to start some motor, with the load, if you want to start some motor, lift, hoist, crane, elevator. So during these in these applications, we'll go for the slip ring type of motor. So starting torque will be moderate, and here you will have a high starting torque. So special type of starter is needed for the slip ring induction motor. So we'll call that is a starter is a rotor resistance starter, and that starter is not required in the case of the squirrel cage induction motor. We have different types of starter: D-well starter, auto transformer starter, star delta starter. Okay, so like that we'll have the different types of starters for the squirrel cage induction motor. Here we'll have a special type of starter. This starter is only designed similar to a DC machine. So DC series motor will have a special type of starter, 2-point starter. Okay, so like that, in the case of slip ring induction motor, we have a special type of starter, rotor resistance starter. And next is squirrel cage induction motor. Speed control by rotor resistance is not possible. So we'll have a different method to have a speed control on the squirrel cage induction motor. Okay, here the speed control is possible by using rotor resistance starter. So rotor copper losses is very low because we are not going to include any additional resistance. Okay, with the armature resistance REA, with that itself we are going to have the output. So it will be efficiency will be more in the case of squirrel cage, and here efficiency will be less due to additional of adding additional bindings. And where you are using this squirrel cage means lathe, drilling machine, fan, blowers, water pumps, grinder, printing press. So these are the areas we are using the squirrel cage induction motor. So slip ring we'll use in where you need a higher torque application. Okay, lift, hoist, crane, elevator, compressors. Okay, so based on the rotor construction, so we'll have only two types of induction machine. One is squirrel cage, another is slip ring. Okay. So these are the main difference between the squirrel cage and the slip ring induction machine. So next we discussed about the slip. Okay. So what is the slip means? We'll have this formula NS minus N divided by NS into 100. So we'll call this as a fractional slip. If the 100 is not available, so we'll get the slip value less than 1. So we'll call that is a fractional slip 0.04, like that you will get. And slip, if you multiply by 100, we'll call as a whole number. In terms of percentage, you will get. Okay, we'll call that is a normal slip. Okay, the slip will be vary from 0 to 1. Okay, so this is the range of the slip value. And what is by slip speed? Means this is the difference between the synchronous speed and the running speed. We'll call as a slip speed. Okay. And next we'll discuss about the rotor current frequency. So we'll have two frequencies available in the case of induction machine. Okay. So what is a in stator? We'll have a F. We'll call as a F. That is the supply frequency. And F dash. What is my F dash means? The frequency generated on the rotor circuit. So if the flux link on the rotor, so in the rotor we'll have a EMF. So the due to EMF we'll have a current flow. Okay. And we'll have a
சார் ஸ்லைடு மாறலாம் சார்.
ஸ்லிப்லேயே தான் சார் இருக்குன்னு நான் மாத்தல. ரோட்டார் கரண்ட் ஃப்ரீக்வன்சி போவே இல்லை. இன்ட்ரோடக்ஷன் கொடுத்துட்டு தான் அங்க போவோம்.
எஃப் டாஷ்லாம் சொன்னீங்களா அதுக்கு?
இன்னும் போவே இல்லை, நான் அங்க போவே இல்லை.
ஓகே ஓகே சார்.
இப்ப நான் அதை எக்ஸ்பிளைன் பண்ணிட்டு தான் அந்த ஸ்லைடுக்கு போவேன் சார். ஜஸ்ட் அப்ப நான் பிளாங்கா பார்ப்பான். So we'll have two frequencies. So this is F dash. Okay. So here if you see, now I change the slide. So generally we'll call as a frequency is equal to general என்ன சொல்லுவோம், NS, N equal to 120F by P. So from that we can take the frequency equal to NS into P divided by 120. Okay. So this is the frequency available on the stator circuit. Okay. So this is the frequency available on the stator circuit. Okay. And what is the N means relative speed between magnetic field and the winding. Okay. And what is my F dash? Okay. So what is my F dash means this is the frequency available on the rotor circuit. So due to flux linking, so they will have a generation of EMF on the rotor circuit and current flow on the rotor circuit, and frequency will be available on the rotor circuit. So what is my F dash means? So in this N I have mentioned as relative speed between magnetic field and winding. Magnetic field and winding means this N, we are going to replace this N as NS minus N. Okay. This is called as the change in speed. Okay. So NS minus N into P divided by 120. So this S into NS can be obtained from the formula. So how will you get NS equal to from the slip formula? We can have a slip is equal to, you can see the board, slip is equal to NS minus N divided by NS. So here you can substitute this NS minus N is equal to S into NS. So S into NS P divided by 120. Okay. And this can be given as S into F. So this, what is this F represents? This is stator frequency and this F dash is rotor frequency. So what is the relationship between the rotor current frequency means rotor current frequency equal to fractional slip into supply frequency. So what is this fractional slip means? It should be less than 1. Fractional slip should be less than 1. Okay. And this is the slip given here and frequency we obtained. Okay. And this can be given as F dash equal to S into F. What is the final equation regarding this means? So F is equal to slip. This is slip is equal to S into F. This is F dash. So F dash equal to S into F. Okay. So this equation we are obtaining with respect to the slip. So when the F dash equal to F, when F dash will be equal to F means if the slip is equal to 1. The slip is equal to 1 means the stator frequency will be equal to rotor frequency. So both the frequency will be same. Okay. So fractional means if it will be less than 1 means automatically this F dash will be always less than the stator frequency. Suppose if we are substituting 0.9, 0.8, 0.6, 0.4. So that is we call as a fractional slip. So at any instant this F dash will not be equal to F. Because you won't, when the slip is equal to 1 means the motor is not running. It is in ideal condition. Okay. Suppose if the slip is equal to 1 means what will happen to the running speed? The motor is not running at all. So you won't get to the F dash will be equal to F. It is not at all possible. Okay. it will be always less than the stator speed only. Okay, up to this, are you having any doubt? If you are not having any doubt, means we will go to the simple problems. So we discussed so introduction to induction motor and what are the types of induction motor. So in that is what is the squirrel cage induction motor, what is slip ring induction motor, what is the difference between squirrel cage and slip ring induction motor. So what is meant by slip, what is meant by slip speed, so what is meant by rotor current frequency. So these are the areas we covered. So in this, are you having any doubt? தம்பி அதுவும் யாரை கேட்டாலும் சொல்லுவீங்களா? எல்லாருமே தூங்குறீங்களாப்பா? ஹலோ,
Hello, sir.
சொல்லுப்பா, ஏதாவது டவுட் இருக்கா?
இல்ல சார்.
எதுவுமே இல்லைன்னா நடத்துறது புரியலையா? ஓகே, ப்ராப்ளம் போயிடலாமா?
எஸ் சார், போலாம்.
Okay. So if you are not having any doubt, means you take the first problem. The question மட்டும்தான் இருக்கும், ஆன்சர் இருக்காது. ஓகேவா? You take the first problem. A 6-pole 3-phase induction motor is connected to 50 Hz supply. If it is running at 970 RPM, find the slip. So what are the data given? So pole is equal to 6-pole, frequency equal to 50 Hz, and running speed. So running speed means n 970 RPM. You are supposed to find the slip value. What is the formula for slip? And you can solve the problem. So slip will be equal to ns minus n divided by ns into 100. Okay. So this n value is given. You are supposed to find the ns. Ns is not given. So what is the ns value? 120 f by p. If you found the answer, means you can tell the answer. So what is the value for slip? Mobile போட்டுக்கலாம் மேடம் எல்லாரும். Okay. Into 100 போட்டீங்கன்னா 0.03 வருதா? You multiply it by 100, Sumant Reddy. Yeah, 3.
No, sir.
You multiply by, in that formula you will have 100. So you multiply by 100.
Okay, sir. Okay, sir.
Okay, 3%. So slip is equal to 3%. You mentioned the percentage. Okay, 3%. So if you complete the first means you can take the second problem. So second problem, a three-phase induction motor is wound for 4 poles and is supplied from 50 Hz system. Calculate synchronous speed of motor when slip is 4%, the rotor current frequency when the motor runs at 600 RPM. And here you can substitute first problem pole in the path 6. You can find the NS value. And then you substitute the NS value here. 970 divided by NS into 100. Then you will get the slip as 3%. So second problem. So pole is equal to 4 pole and frequency is 50 Hertz. So you are supposed to find what is NS. N at slip is 4%. And the third subdivision, rotor current frequency. And you can write the formula N is equal to 120 F by P. And frequency poles are given, you can find the slip is equal to NS minus N divided by NS into 100. And the slip is given and N is given, you can find the, what is the second one? Speed of the motor when slip is 4%. And for 4%, is the first one. 4% you can find the new value of N. And third one, you are supposed to find when N is equal to 600 RPM, you have to find the F dash. So tell the first value. What is the NS value?
Sir, 1500.
1500, okay. As 4 pole na 1500, okay. Second, for 4% slip, what is the N value?
Sir, 1440, sir.
1440, okay. 1440. So for this case, you substitute 120 into 50 divided by 4, you will get 1500 RPM. So second case, you substitute 0.04 is equal to, so N is 1500 minus N divided by 1500. So we find the N value. And third case, for N is equal to 600 RPM, You are supposed to calculate the new value of slip. You have to find the new value of slip. You should not substitute this 4% here. Okay. So directly you should not substitute this 4% here. You find the new value of slip. Slip is equal to 1500 minus 600 divided by 1500. Then you will get a new value of slip here. That you have to substitute here. And this frequency is 50 Hz only. So new value of slip here you have to substitute and you tell the f dash. So second subdivision 1440, okay. What about third subdivision? $60. தப்பா இருக்கே பாரு, செக் பண்ணு. விட்டு. So what is a f dash value? Tell in terms of hertz. F dash value will be in terms of hertz. And I already told that this value S is a fractional slip. Here you have to substitute as a fraction. Fractional slip. What is the fraction? The fraction should be less than 1. So if you are getting this slip value as a 60% example, then you have to substitute as a 0.06. Okay, this we'll call this as a fractional slip. And here if you are not using 100, you will get a fractional slip. If you use 100 means you will get 60%. And as per the rotor current frequency formula, so we'll have this formula as a f dash, this is rotor current frequency equal to fractional slip into stator frequency. So here you should not substitute as a percentage, you have to substitute as a fraction. So what is a 3? What is a 3 in 106? So this is the answer. You can check the answer for example 2. So NS is 1500. So second value is 1440. So third one 0.6 தான். நான் அது எக்ஸாம்பிளுக்கு தான் எழுதுனேன். நீ அதை அப்படியே பார்த்து காப்பி பண்ணிட்டியா? 0.6 into 50 Hz. 0.6 into 50 Hz, you will get to 30 Hz. So you have to remember this fractional slip and slip. Difference between fractional slip and slip. So slip is will be in terms of percentage. Fractional slip will be in terms of value, numerical value. Okay. That you have to consider. You should not confuse with the fractional slip and the normal slip. Normal slip will be in terms of percentage. And that 0.06 is a fractional slip because we are not multiplied that with 100. So are you clear with this example 2? Where a doubt irukku, shall we move to the next problem? Are you having any doubt? Okay, next you take the third problem. A 6-pole alternator running at 1000 RPM supplies an 8-pole induction motor. Find the actual speed of the motor if the slip is 2.5%. So you are supposed to calculate actual speed n if the slip is 2.5%. Meenakshi Sundaram,
Sir,
answer கண்டுபிடிச்சிட்டியா?
sir, not yet, sir.
ஏன்பா? ஏன் அது 2 mark ப்ராப்ளம் தான் இதெல்லாம். ஏன் ஆன்சர் வரல? டவுட் இருக்கா?
ஒரே நிமிஷம். இல்ல சார்.
சரி சொல்லு, ஆன்சர் சொல்லு, போட்டுட்டு சொல்லு. So first you calculate the NS value for 8 pole. So 120 F by P, and this P you can substitute as 8. Then you will get the synchronous speed. Okay. And next you are supposed to calculate the N value. So from this slip NS minus N divided by NS. So this slip value you know, and the NS you found, you tell this N value. If you tell the answer means we will wind up the session. It's almost 12:44. So from the next class, kindly bring the calculator. Calculator இருந்துச்சுன்னா தான் போட முடியும். சும்மா வந்து அட்டன் பண்ணீங்கன்னா யூஸ் இல்லை. Okay, so you can refer this answer. So you should get 731. So frequency is not given means if from the pole you can calculate the frequency. Okay. And here, what is that the frequency? How we are going to calculate means? So here it is given 6-pole motor running at 1000 RPM. So from that you calculate the frequency. For that only that speed is given. Okay. So that is 1000, not 100. So F is equal to NP divided by 1000 and 120. So here you can substitute 1000 into 6 divided by 120 will give the frequency. Then NS you can calculate. So we'll get 750 RPM. From the slip value you can calculate the N value. Okay. So that is for that only it is given as here 100 RPM. This 100 RPM is given to find the frequency. This 6-pole and this 100 RPM is to find the frequency. Okay, we'll continue this same problem in the next class. Okay. So we'll if we are not completed means we'll discuss in the tomorrow class. No problem. Okay, thank you.